Hi guys, and welcome to this training session where we're going to take a detailed look at how to fault find on a heating system that uses the products from the Drayton control packs. The type of heating system that we're going to look at here is where there is stored hot water, and this falls into two categories known as biflow and twin zone, but you're probably more familiar with the terminology Y-plan and S-plan. This aligns with two of our control pack ranges, and in these examples the hot water cylinder is vented, so it uses a Drayton HTS3 cylinder thermostat, but the same principles apply should the system have an unvented cylinder. One of the most important things when fault finding is keeping track of what you've done already so that you don't get lost in the process, which is why it's a good idea to first come up with a fault finding plan. There are two parts to the fault finding plan. Firstly, some test routines to try and identify where on the system the fault lies, and this can be done without the need to remove any covers and doesn't require the use of any test equipment. Once you've identified the part of the system that isn't responding as it should, that's where we need to start doing some electrical testing to pinpoint the exact cause of the problem. But before we start this, there are some prerequisites. Firstly, you need to be confident working on live equipment, as most of the faults only present themselves when the system is energized. Next, it is important to have a wiring diagram of the system that you're fault finding so that you can keep track of what needs to be tested. Thirdly, you need to have a multimeter which is able to show you the precise voltage that is being measured, not just a volt stick that can indicate if voltage is present or not, and this is particularly critical for fault finding on a Y-plan system, as the voltages you need to measure are not simply 0 volts or 230 volts, it's voltages in between. For safety, your multimeter should also have fused test leads. Lastly, you need to be able to identify how to safely isolate the system and lock it out, should you need to do any work on the system whilst dead without it being accidentally re-energized. Begin at the programmer by setting both of the channels for heating and hot water to the off position, and also turn off the power to the fuse spur. Next, check that the motorized valves are in the home position, and for the mid-position valve, this is the W position, and for the 2-port valve, the valve actuator should be in position A. If the valves aren't in these positions when de-energized, it could be that there is an issue with the valve body preventing the actuator from moving to the correct position. If this is the case, remove the actuator and recheck the position when the actuator is removed from the valve body. Assuming the issue isn't with the valve body, re-energize the system with both channels of the programmer still set to the off position, and make sure that the valves don't move from their de-energized position when the power is reinstated. Next, select the hot water on the programmer and call for heat by turning the cylinder thermostat up to maximum. On the mid-position actuator, the valve should stay in the W position and the boiler and pump should fire. For a twin zone system, the actuator will start to progress from position A, which is closed, to position B, which is open, and similarly the boiler and pump will fire. Next, set the heating channel on the programmer to the on position and turn the room stat up to maximum. The mid-position valve should now start to progress from the W position and stop at the M position, as we are calling for both central heating and hot water. The boiler continues to fire. For the twin zone system, the central heating actuator will progress from position A to position B, and the output of the boiler will be maintained. Next, turn the cylinder thermostat down to minimum, and the mid-position valve should progress from the M position to the H position, and the boiler continues to fire. On the twin zone system, the hot water zone valve will close by moving from B to A, but the boiler will continue to fire as the central heating zone valve is still open. Turning the cylinder thermostat back up and turning hot water off on the programmer should have exactly the same effect. Next, turn the room thermostat down to minimum and you should see that the mid-position valve remains in the H position, but the output firing the boiler will cease. On the twin zone system, the central heating zone valve will close by moving from B to A, and the output that's firing the boiler will stop. Turning the room stat back up and turning the central heating channel at the programmer to off should also have exactly the same effect. The mid-position actuator will sit in the last called for position, in this case heating, until there is a subsequent call for hot water, in which case it will traverse all the way from the H position back to W. Begin by isolating the power to the system and confirm that the actuator is dead. Next, remove the actuator from the valve body by pressing in the square button and lifting upwards. This will give you better access. Next, undo the screw on the actuator and the casing hinges open to reveal the internal components. The two orange wires feeding the motor are connected using 𝗿𝗱𝗱𝗀𝗀 connectors. Grab hold of the connector and pull off of the terminals on the circuit board. With the wires disconnected, locate and undo the two retaining screws to release the motor. The heatsink and the motor can then be removed. The actuator is now ready to be reassembled with the new motor. First, position the heatsink so that the holes align and then insert the sprocket of the new motor through the larger hole so that the teeth mesh with the gear rack. Next, align the screws with the screw holes and tighten, making sure that the motor mounting plate and heatsink are aligned and secure. The two 𝗿𝗱𝗱𝗀𝗀 connectors on the end of the new motor can now be connected to the terminals on the circuit board. Polarity doesn't matter, so the wires can connect to either terminals. Lastly, replace the cover by positioning the back edge underneath the two retaining clips and hinging forward so that the retaining screw aligns with the screw hole and can be tightened. Make sure that the wires don't get trapped by the casing. The actuator can now be clipped back onto the valve body and the system re-energized. The new motor can be tested by calling for heat and ensuring that the indicator now moves to the correct position. If you need any more help, the Drayton website is a great resource, and under the Installers tab there is a training centre and resource section where you can get access to all of our wiring diagrams that cover all the different control packs, including different wiring centres and different thermostats. I normally download them as a PDF and then I can zoom in on the relevant areas. Thanks for watching this training video, and if you need any more information or resources, head over to our website, draytoncontrols.co.uk.